So remember we said that the log b to the x and the log base b of x are inverses. Now, what is an actual log? The log is actually reducing a number to an exponent on a base. So for example, the log base 10 of 10 is equal to 1. Why is that? Because 10 to the 1 is equal to 10. And sometimes we refer to this as the log form when I write it as a log, and an exponential form when I write it as an exponential equation. But these are equivalent equations. These are the same equation, just written in different forms. Let's take another example. Supposing we want to know the log base 10 of 100. Well, that's equal to 2. Why is the log base 10 of 100 equal to 2? Because 10 squared is 100. 10 squared is 100. So the log, what it does, you're logging 100, base 10 log of 100. You're reducing that 100 to 2, because 2 is the power on 10. That gives you 100. Let's take a few more examples. So if we want the log base 3 of 9, that's going to be 2. Why? Because 3 squared is equal to 9. And let's just think about it in abstract terms. If I have the log base b of x equal to 5, what is the equivalent way of writing this equation? B to the 5, we're saying b to the 5 equals x. Or if we have the log base 2 of 7 equals y, the equivalent way of writing this equation is 2 to the y equals 7. So these are equivalent ways of writing equations. Remember, when we use the log form, we call it the log form of writing the equation. And then if we make it into the other form, it's called the exponential form. And sometimes we need to do that in order to solve an equation, go back and forth between the two forms. So we're going to examine the log function in a little bit more detail. What we want to talk about is the domain, the x-intercept, and the vertical asymptote. So we will note that the domain, remember we said, of the y equals log base b of x is greater than 0. So we go from the y-axis onwards. The x-intercept of the function as it's written is just x equals to 1. Why is that? Remember, the log of 1 is 0. So you might want to make a note of that. The log of 1 is 0. And also, the vertical asymptote is the y-axis, x equals 0. So the vertical asymptote is this line here, which is, in this case, the y-axis. Now what happens if you shift this log function? So let's say I shift it forward, and you could be shifting it backwards too. What happens to the domain, the x-intercept, and vertical asymptote? Well, let's take a look at that. So we want to find the x-intercept, the domain, and the vertical asymptote of this function y equals log base b, or let's say x minus 2. Now the first thing you want to find is you want to find the x-intercept. Remember, the original function, the log of 1 was 0. So to find the x-intercept of this function, we let the argument x minus 2 equal to 1, because the log of 1 is 0. And we solve this for x, we get x equals 3. That's the x-intercept. So the x-intercept is x equals 3. The second thing we want to look at is the domain and vertical asymptote, because they are related. Notice that, remember, the log of 0 was undefined because x was greater than 0 for the original function. So in this case, x minus 2 has to be greater than 0, because you can't log negative numbers and you can't log 0. And we solve this for x, we get x is greater than 2. This is my domain of this function, of this new function, my domain. You could also think of it as the original function shifted right 2, because we'd subtracted 2 from the x. That means we're shifting right 2. And finally, the vertical asymptote is going to be right here, in this blue. That's the vertical asymptote. And what's the equation at vertical asymptote? Well, x equal to 2. So So notice the domain is x greater than 2, and the vertical asymptote is x equal to 2.